Dun 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 dun. All right, so I'm going to get started here as I organize some things. So first, going through some questions that were coming through. I have had some audio problems. I think there were only two videos I had where audio didn't come through. I've been actually watching them periodically. It's hard to record this much content and then edit all of the content. So if there's a problem with sound or video in any of them, send me a link to it. Now, what I'm going to do here is I'm going to show some different things in the web browser. So here I am on the course content of one of the two sections. And course content is over on the side here. And I am putting different pages out for the different things we're doing. I'm also building some folders to put all of the lectures in, and I'm going to eventually have everything in folders by chapter as I organize things. But the important things for us currently are going to be the due dates for chapters 3 and 4. Now when I open this, it goes right to edit mode. And we'll see that I have the lectures I have done on those chapters. I have a link directly to example problems. Now I have not put the link directly for the example problems in chapter 4. And then I have the online exam. And the online exam is now up in Pearson. I'll show you that in a second. But so this page is collecting everything for chapters 3 and 4. But what I did was for the YouTube lectures, there are two, and let me get both of them in. Link to just this class. And that's the problem with this having two sections, is I have to make copies of everything I do in between the two sections. And so I'm using this lecture time to put these together. And so this has a copy, the YouTube lecture has a copy of all the lecture stuff I have, any subject matter, and specifically this class's videos. Now, unfortunately right now I'm having a hard time. You still having no sound? Still no sound? Choppy sound. Okay, let me see what's happening here. Good sound from there. Okay, so the choppiness is probably connection oriented. Double check your sound settings. I've got sound going through. And okay. All right. Okay. Coming back. And look, we have a browser within a browser. What I tend to look for here is I can ping off of the YouTube site, and it bounces back the sound quality, and I can see what's happening. Now then, you pick up from the site here, and sometimes there can be things in the middle of that. All right, so going back here. And so now in the Pearson, material, what I wanted to say here was that for the Pearson stuff, this is all the homework we've had. The homework for chapter 4, which was due kind of this Sunday, coming across. It would have been due when we would have been back last week, but I pushed it forward a week. And then the 2 in-class worksheets that I handed out before we left, and the one we would have been doing this week on chapter 4, I turned into quizzes. And they're up here with finishing chapter 3 this week and finishing chapter 4 next week. Then the exam on chapters 3 and 4 is due by the end of next week. And one of the things to notice about the exam is if I look at the settings for it, I have to re-log in because I've been sitting on this for a while. Give me a second here. Well, that's unique. Let's just go back here. There's that. There's that. That's looking better. manage assignments. And so we're going to look at this assignment here, and I'm just going to pull up a quick edit to it so that we can see. If I look at the settings, you have 3 attempts at the exam. Because an online exam is something completely different, I've given multiple attempts so that you can get used to it. I don't want it to be the stressor. And so the online exam will have 3 attempts. So that's on Pearson. All the due dates are up on Pearson. All the links to the material are coming about. And let me show you what the playlist looks like on YouTube. Again, ignore the stuff YouTube recommends for me. Let me get to the actual playlist itself. So here is the MAT 143 2020 playlist, which has the playlist of all of the videos I recorded and labeled for this class. And my neighbor's bringing his trash bins back. You can hear him rumbling everywhere. All right. And what they'll do is I'm trying to put them in order so that the lectures will come first, and then any review or example questions I have where I've worked out an example question will come down. And so I'm going through the review packet. I'm halfway through the review packet for Chapter 4, and I do some examples if you have a TI-30 versus you have a TI-84. I haven't done any examples using the tables yet. Most of you have one of the 2 calculators. I will probably, if you need another calculator or another example, email and let me know, and I'll record on a need basis. But I think between most of these, you'll be able to go through. And I'll probably be finishing off the second review packet tonight. I do kind of have to do a similar thing for my 162 class, where I'm doing example problems for them. And as you can see, I have some different classes. I have an 092, a 162, and a 143, and a Phys 101 in the spring semester of 2020. And I've already actually started creating room for other things. But everything you will need will be from the MAT 1/4 Spring 2020, which we have the link for. And that link is in the course contact in the YouTube videos, in the email I sent out to everyone yesterday. I have found, because things are in different places from how I normally do class, and I tend to do my class discussions. Let me change here. I'm going to change to where we're going to go next while I continue to talk a little bit. There we go. I try to hand things out in class, and I didn't use Blackboard as a centralized place. That I'm probably going to do a weekly email, and it's probably going to be Monday or Tuesday evening, because I will have had a chance to talk to everyone in class on the Monday class or the Tuesday class. And when I mean everyone, it's the people that show up for this and to see where we are. So that's all the administrative stuff I have, where everything's at. Continue to send me email questions, and we'll work on the material as we go through. Chapter 5 PowerPoint is still corrupted. That's odd, because I downloaded it and it comes through perfectly for me on 2 different machines. I'm going to delete it completely and rebuild it in both places. In fact, I'm putting up all the PowerPoints for all the chapters. I'm working my way through that right now. I will just reset Chapter 5. So I'm actually grabbing a piece of paper on my lovely to-do list here. 2 seconds. I'll do the Jeopardy theme. I'll hum that while I grab my paper here. Okay, Chapter 5, PowerPoint, completely reload. And I'll have to make a note both sections, because there are 2 places I have to put that up for MAT 143. All right, thank you, Bill. Okay, so, but you were able to use the PDF. Okay, yeah. It's weird the way Blackboard does it, and it's similar to what Canvas does, which I've used before. Blackboard, if you click on the name of it, it would download the document as it's in its original format. If you click on the little, looks like a capital A off to the side of it, it gives you an option to convert it to different forms, and convert to PDF is one of the forms it has. I will figure out what's up with that. I'll just start it from scratch. I do not have a Microsoft machine. Oh wait, my son does. I will check it on a Windows machine. I've got a Linux, and my wife has a Mac, and my other son has a Mac. And I've got I've got 5 boys, or no, 4 boys and a girl, all in school with all their different laptops. So I'm doing an inventory. I have a Windows machine that I have access to that I'll test it on, just to make sure it's opening in Windows stuff. All right, now we're continuing on chapter 5, and I really, really want to stress here. I did a couple of things here now where I should be able to write on a PowerPoint, and you'll be able to see that. I don't like PowerPoints in general. There's a lot more I need to add and talk about on this, but you'll hear me probably mention this as we go on and on. What the best way of teaching with PowerPoints for me, and I think Aisha had this in the class she had before, if the PowerPoint can be on one side and I have a blackboard off to the other side. I prefer that. The classroom we were in didn't have the ability to do that, so I was kind of taking the PowerPoints and putting them up on the blackboard, which slows things down a bit. Here, I have to switch screens between the two and seeing the two things at once. I found if I tried to split the screen and have my blackboard on one side and the PowerPoint on the other side, it's just really small visually coming through. So I'm going to do the best with what we have, and we're going to talk about. I have found that the PowerPoints Pearson offer are really good bullet points. But as with all bullet points, there's information you need in the background, and I really, really want to expand that information coming across. And I will try to do that in the same format that I've done before, working out examples off on the side, and I will record other examples as need be. So we might find some back and forth coming through here. All right, so moving things around so that I can get to my tablet. There we go. All right, rearranging my desk. I'm going to turn this to a standing desk. I found sitting down is not my thing. You saw me in class. I jump up and down, and sitting here just isn't working. So here we go. Standard normal distribution. This is kind of where we ended. This is a review and a deeper dive into everything we did in the last section of chapter 2. So if you want to go back to your notes, section 2.5 and 2.4, and look at how we observed distributions. We observed z-scores. We observed standard deviations. Now we're going to say, hey, if things are random, they will make this thing, this normal curve here, is what they'll make. And good, I can still see the chats here. And so we create a standard normal where we're going to put our mean, go back, our mean at 0. If I press too hard on the pen, it thinks I'm clicking it. Okay, I hate red, so we're going to go to blue. And so our mean is at 0. One standard deviation, this is what happened in my 162 class, tells me where the turning points are. And in between there is 68% of the area of the curve. And so the standard normal is a way of making this curve generic. The data that we look at we could talk about any curve. I could talk about one standard deviation away from the mean and the numbers I could compute from the standard normal distribution. And so we're going to look at the standard normal to give us things to calculate, but then we're going to slap it on something where the mean isn't at 0, the mean is somewhere else. Or we're going to look at something where this standard deviation is not 1, it's much, much wider. But the things we do here will work for all those other things we do. So what we can do is add up all the area underneath the curve. And so the cumulative area, if I start here at 349, negative 3.9, I'll have to use the mouse. If I start at negative 3.49 and go to positive 3.49, the area under here is, notice, close to zero. It's not exactly zero, but the area under the curve is very, very close to zero at that point. And as we progress up to positive 3.9, we get an area that fills in. That area is equal to the probability up to that point. So when we talk about cumulative, we start at 0, and when we get up to here at the mean, well, everything in there is 50%. Or there's a 50% probability on being at the left of the mean. There's a 50% probability of being to the right of the mean. And so we're going to, this area that we see underneath here, if the area adds up to 1, all the area is 100% probability. Any portion of the area is the probability of being in whatever wedge we're looking at. And so as the z-scores increase, the amount of area that's cumulative increases. And so as we get close to positive 3.49, the total area, the area from here all the way to here, everything we filled in is close to 1. And we have to say close because this curve never touches the axis. It never truly gets to 0. And we can get more and more accurate or precise if we want. And so for the type of mathematics we're doing, negative 3.49 to positive 3.49 is 100% of everything, almost. Okay, so if we want to find a cumulative area that corresponds to a particular z-score, what we want to do is we want to find that score on our graph. Let me get rid of my scary people. And so I'm going to put my axis at 0, and then I'm going to come across here. All right. Now I'm going to try to give a freehand bell curve. I never touch the x-axis, so this goes here. And I'll try to do my freehand here. Sorry about that. This got half decent with this on the board last year. Well, now I have to get used to it on the tablet. And so that's my -1 standard deviation and +1 standard deviation. Well, the z-score I'm looking for is 1.15. So 1.15 is a little bit past here. So I'm looking for a z-score here. And when it's asking for the cumulative area, is it saying, hey, if I fill in everything under the curve up until my z equals 1.15, what is this area? Or what is this probability? So, Blackboard. And so there's my z-score of 1.15. And I'm looking for all the area from 0 up until I get to the 1.15. Well, to do this, we have to add up every infinitesimally small slice. And what mathematicians did is they pretended there were little rectangles, like a histogram. And they added up the total area of the little rectangles. But what they did by using calculus was they made it so that it had a width of 0. So they were infinitely small. Okay, so Jay just asked a question about a z-score table. And let me go through here, because that's what we're going to use. So we add up these. I'm going to come back to your question in 1 second, Jay. I'm going to get to it because we need to look at it. So we add up all these infinitely small things. And to do that, we add up delta x's times the height of the function, which is the probability at x. Right? And this was similar to how we did other computations. But because those delta x's got really small, they become a thing called an integral. And they look similar. An integral stands for a sum, and it's a sum of infinitely small things. Going to what Jay was saying, the integrals were already calculated by mathematicians, and so they're done in tables. Now, let's see here. If I go back, cancel out. All right, so there are 2 sections, and let me get this here. All right. So both sections now should have the front matter of the textbook, which is a PDF here. This is in both sections. On both G1 and G2 have it. Now, if we pull this up, I'm going to try to open it in another window here. It has the fold out that was in the textbook with all the key formulas, right? So here's the stuff we were doing in chapter 4 with the different properties of a binomial or a geometric distribution. And here we are in chapter 5 where we're starting to talk about z-scores and we're working our way towards the central limit theorem. And again, I'm hoping that we see, hey, look, z-scores were at the end of chapter 2. So something similar is going on here. But further in this are these standard normal distribution tables. And it's table 4. It's also in the appendix of the book. And so using this PDF, we can calculate the area under the curve because it's already been calculated for us on some different things. There's a t-distribution we'll look at later, and there's a standard normal and standard normal. And standard normal is what we're looking at. So, to go back to the problem that we have, and using these tables now that are in both sections, and thank you for pointing that out, Jay, we want to find a z-score of 1.15. So on the table, come back to my table, I need to find a z, okay, if you see my mouse here, of 1.1. And then this has all of the next decimal values. So this is 1.10. This is 1.11. This is 1.12. And notice how it alternates in color. So I'm noticing 1.1 is gray and 5 is here. So when I come down, 0.8749 is the area under the curve that goes up to a positive 1.15. So the area under my curve up to a z-score of 1.15 is 0.8749. Well, if we're going to say this is similar to a probability, it's saying the amount of stuff, the probability, if I chose randomly, of getting something before a z-score of 1.15 would be 87.49%, or a probability of 0.8749. if I were to just randomly choose from whatever generated this probability distribution, and if I knew it was normal, my chance of getting something before 1.15 would be 0.8749, or as we like to say, 87.49%. And so the area and probability are going to be related terms. And you'll hear me talk about it more as probability than I will about area. All right. Well, notice the chart has left-sided areas. The area is to the left. If I wanted to talk about the area to the right, stuff in here, it's the complement. And so if I could talk about what were my odds of getting more than 1.15. If I'm talking about the odds of getting more than 1.15, if I'm talking about, let me put my blue here, if I'm talking about being over here, right? So the probability given a z-score of equal to 1.15, where the area under the curve was 0.8749. Well, if I want to talk about the area here, the probability of having falling into z greater than 1.15, well, it's the complement. So it's 1 minus 0.8749, or what is that? 1.251. And so I have a 12% chance of landing in this part of the curve if I were just random. So the thing that we want to see here, and the thing that z-scores and standard normal scores do, they're like the histograms from the probability distributions, and they're the chances of falling into a certain bin. But because our variable is now continuous, we have to talk about ranges. Ranges up to a z-score, after a z-score, in between two particular z-scores. Now pull my scribbles down. And so area turns into probability because the total area is 1, total probability is 1, or 100%. And so if we take any wedge in our z-scores, those relate to a chunk of the standard normal. Right? And so we're going to work our way through some different examples. Now notice on the TI-84s, there is a normal cumulative distribution function. And I'll do a video of using those separately as I run some examples coming through. Now that we're in new material, I will do some of these examples out in individual little slides. But you'll look for it is under that distribution, that second distribution. A lot of the probability distributions and the things we're going to use on the TI-84s are in the second end distribution. For the TI-30s, you want to use the table. Use the table, use the table. All right, so if we want to find a cumulative area that corresponds to a z-score of negative 0.24. So again, I'm going to come back here and draw it. And I know we ended with this last time, but I am repeating it because it is important. It is some of the most important. This is the most important part of statistics. This gets you through being able to do any predictive statistics, being able to work with any statistics, because we will find as we do the central limit theorem, things approach normal. Right? I hate the word normal because we have a psychological connotation with it that's slightly different than the mathematical, but we'll see some examples where we can see where our psychological connotation with it and our mathematical relationship come together. And this is symmetric, all right? Don't mind my bad drawing. And so we're looking at a z-score of negative 0.24. Where am I looking? Cheryl, what do you mean, where am I looking at? Am I pointing to something that isn't the charts. All right, so the chart we're looking at will be table 4, and I'll show you this on table 4. So we're at negative 0.24 is the z-score we have. And so I want the cumulative area under the curve up to negative 0.24. So I'm going to come back to my chart here. Now, these charts are on, Bill sent a copy of the PDF out, it appears, but they are also on Blackboard. They are in a file called Front Matter of the Textbook, Tables and Formulas. Table 4, there are 2 of them. Now notice, they're telling you where it's shaded in. And on the first table, all the z values are positive. Positive z values are after the mean. They're to the right of the middle. The second one, still shaded to the left, but it's to the left of the mean, and so they're negative z-scores. And so it's a negative values. And it looks like this is on page 6 of the PDF, if I look up in the corner here. So the z-score I'm looking for is going to be negative 0.24. So to get to negative 0.24, or to calculate the negative 0.24, I need to come down to negative 0.2, because those are the first 2 digits of my z-score, negative 0.2, and then I need to come over to 4. Now notice on the negative side, we count down from 9 to 0. On the positive side, we count up. So I need to come down to 4, which is going to be this column here, and over to negative 2. And so my probability of having a z-score of falling in the area before a z-score of negative 0.24 is 0.4052. So my probability with a z equal to negative 0.24 is, let me quote that number, 4052. 4052. 4052. 0.4052. So the area under the curve is 0.4052, or the probability, if I randomly chose something, of falling into here would be 0.4052, or 40.52%. I'm going to keep jumping in between these words of probability and area, probability and area. Just a clarification, these charts are the same charts in the book table 4. They are in both the appendix and the fold out in the front. There is a PDF called the Front Matter of the Textbook in both sections now. All right. So I'm going to do the same thing here. If I want the probability of landing anywhere in this part after z of negative 0.24, well, I want the complement of this. And so the complement of z equals negative 0.24 is 1 minus the probability. And this is why we spent time looking at probabilities, is we need to be able to slice and dice the different probability areas that we get up. And so this is 0.5948. And so my probability of landing to the right of a z-score of negative 0.24 is 59.48%, or 0.5948. This is one of the keys here. Some books have tables of both the left side and the right side. Most books and most tables only have the left side. Now in reality, sometimes you want what's over here. Sometimes you want what's over here. And so you have to switch them back and forth. Well, instead of printing volumes and volumes of tables, we use the complement to get the right side. All right, and so we find that, and here it shows us in the slide on how, here on the slide it shows us how we find this on the table. Coming across. Again, there's the CDF key on the TI-84s. I will do a video on the TI-84 separately. All right, so when we go to find areas under the curve, we want to sketch the portion we're looking for. We want to mark out where in the standard normal we're looking. And then we want to trace in the probability we're looking for so that we can kind of organize our thoughts. And so they're going to show the different cases here on how we find the probabilities and we come across. So to find the area to the left of a Z value, it is the area that you look directly in the table. And so here's an example. We're looking at a Z-score of 1.23, and the area shaded in blue is what's to the left of the Z-score. So I would go to the table, and I would go down to 1.2 and over to 3, and you would find 0.8907. So here, what we're looking for, this area would be 0.0987. So we find that score and we get the 0.8907. It's the area of the shaded bit. But notice the catch in these instructions. Find the area to the left of the Z-score. Right? Well, if we want to find the area to the right of the Z-score, we have to do the complement. And so here is the other side of that value we just looked at, and we do the complement. So I have the area, the Z-score of 1.23 is 0.897, or 0.8907. Let me get that O in there. But I want to go to the other side. So I have to subtract the area from 1 to find that. This is why we looked at discrete probability distribution functions, why we talked about the complements of probabilities, why we kind of did some slice and dice problems where we looked at different things. All of those techniques are going to come back with Z-scores, but because Z-scores have these infinitely small things in them, we've got to kind of grab these values and either subtract from 1 or add and subtract. And so what you want to look for is, I'll go back a few slides here. If I'm to the left, it's the value that I get from the table. If I'm to the right, it's 1 minus the value I get from the table. But the fun part, yes, math fun, is when you want to find between two Z-scores. And what you have to do is subtract the smaller area from the larger area. So if I have two Z-scores here, and I want the area in between them. So Bill asked a question, how does it show in a formula? This isn't really a formula per se. It's a probability distribution. We look at the probabilities given a particular value. The formula for it, here. So the probability, the cumulative probability of a particular z-score is equal to 1 over the square root of 2 pi of the integral of e to the minus z squared over 2 with the term being dz. And so what the table did was calculated all these values for you. So this is the actual probability, and it's from negative infinity to the z you're looking at. What ends up happening is the tables work all of these out for you, and you look them up for the table. So if you are trying to find the probability up to a z-score, you get the value from the table. If you're trying to find the complement of it, which is to the right, so that's to the left, and this is to the right, it's 1 minus from the table. Now, if you do scientific statistics or ever doing lab results, you start working with these type of probability distributions and the integrals. But for us, we have the tables, and the tables are accurate to 4 decimal places, so that works out really nicely for us. And so where I wanted to go to drawing-wise here, and I'll see if I can get these numbers right. I will work on my freehand normal distributions as I go. It's my left hand, the microphone stand is just right where my left hand wants to be. Oh well. So we're looking for the area in between. So we're looking for this area in between 2 z-scores. And the particular values we have are negative 0.75 and 1.23. Now, I'm going to try to visualize something here. If I found all of the area up to 1.23, I would find this value here, right? I'd have things starting at 0 and going up to 1.23. I'd fill in all of this. But somehow I need to take off this left-hand bit. Well, that left-hand bit is all of the area up to negative 0.75. So the area up to z equals 1.23 is everything from negative infinity up to this line here. It fills in all of this. So I'm going to look up that number, and that's going to be my bigger area. But I need to subtract from it what's over here. And what I'm subtracting from that is my p of z equals negative 0.75. So if I have my whole thing and I subtract this out, I'm left with just the orange bit in the middle, which is what I wanted to find. It's the orange bit is the stuff in between my 2 z-scores. So when we look for the area between, so between 2 z-scores, it's the value of the bigger minus the value of the smaller. And so I'm going to come to my browser here, and we're going to try to stop being so meta. And we're going to look at 1.23, which is the 0.8907. So I'll come back here. And this is 0.8907 minus, and now I've got to look up this z-score. Right. So I've looked up 0.8907, I've replaced this with it, and now I'm going to subtract the z-score of negative 0.75. So I have to go down a table, and I'm negative 0.7 and over to 5. So here's my 5 column, and that's 0.2266. 0.2266. So the area of the purple bit, everything in here, was 0.2266 is the area in here. And the area of the white bit, everything up to here, was 0.8907. But I just want the area in the middle, so when I subtract those two, I get 0.6641. Oops. And so 0.6641 is the total area in the orange. Everything in the middle is 0.6641. And so when you are between two z-scores, subtract the larger, or subtract the smaller from the larger. Subtract from the larger the smaller one. And that will give you the wedge in between. All right, so Cheryl, the PDF you can download if it's from the PDF part, and the video you can rewind if you need to do a copy from it. The video is not transient; it'll come back. Oops. Which part are you looking for? Why is this doing this weird thing? Ah, there we go. And this is everything I did on the blackboard separately here. I'll put it up here. Is that we find the area between the two parts. I try to sketch these out and shade in the part I'm looking for. If there are two z-scores, it's always the probability of the bigger minus the probability of the smaller. If you're to the left, it's what comes from the table. And if you're to the right, it's 1 minus what comes from the table. And so those are the different things they say here. So if it's to the left, you get the z-score that corresponds in the table. And so for the left, it's the z-score in the table. For the right, you subtract what's in the table from 1. So in this case, you find the z-score of 1.23, you get the 0.8907, and it's 1 minus it. And if you're in between two scores, you subtract the bigger score from the result from the bigger score You subtract from it the result of the smaller score. All right. I'm going to do this example as a separate video, but we have just done an example of all three cases. We've done to the left and to the right, and we've worked our way through different z-scores. What I want to look at is what the z-score means in the case of statistics, where we get what z-scores are doing and how we can use them. So let's go through here. I hope that didn't give a odd setting there. All right. I'm fighting. Let's see if this works. Ah, yeah, okay. There we go. Sorry about all that. When I move a window, sometimes the sizing comes through. So we're talking about areas, and I've been trying to translate my language into probabilities. And so the first section in chapter 5 talks about the areas of the z-score, the area of the z-score, what the area under the curve is. We're going to talk about this in probability terms, and I've been trying to mix my language to segue into this. If a random variable is normally distributed, you can find the probability that x will fall in a given interval by calculating the area under the normal curve. And so that area and probability end up being the same thing. And so the notation that we're going to get for this is if we look at a normal curve, we can talk about the numbers coming across. And so in this normal curve, this variable is randomly distributed. Notice it has a mean of 500. And it has a standard deviation of 100. And so we're looking at the probability that we're going to be somewhere around 600. We were looking up z-scores, so I would need something to turn these numbers into z-scores. And this is where our formulae from chapter 2 come in really handy. So I'm going to come back here, back to the front matter in the book. And notice we could calculate a z-score if I had x minus the mean divided by the standard deviation. We did that in chapter 2. Well, notice it pops back up here in chapter 5. The z-score is x minus the mean divided by the standard deviation. So I'm going to put that up here on the blackboard. If we want to find a z-score, we take our given x value and we subtract from that the mean, and we divide it by the standard deviation. So this is saying we have an x value of 600, a mean of 500, and a standard deviation of 100. An x of 600, a mean of 500, and a standard deviation of 100. Plugging that into here, I get 600 minus 500 divided by 100, or 100 over 100. We have a z of 1. And so, if I jump back into my slide here, and I'll jump ahead a little bit, if we do that calculation and we have a z-score of 1, it means our positive value, getting everything up to the curve here, is the same as having an area under the curve as if the standard normal was 1. Notice, I went from some data that wasn't a standard normal, and by calculating its z-score, I can compare it to a standard normal curve. That's the power of this. I also need to make sure I can see your chats. There we go. Is that we can take any mean and standard deviation and we can overlay it with a standard normal. So if things happen truly randomly, we can use those probabilities to describe our data set. And so everything that comes from the standard normal, if we calculate a z-score for our data, we get the cumulative probability. And we now know what our chances are of randomly grabbing things out of this data set. So let's put one together and let's work on the larger and complete idea here. And so we want to assume that something is normally distributed. And so this says in national, I'm going to, all word problems, read the problem through once and then break it down into components. Right? So I'm going to read through this once. National study found that college students with jobs worked an average of 22 hours per week. The standard deviation is 9 hours. A college student with a job is selected at random. Find the probability that the student works for less than 4 hours per week. Assume that the lengths of times that college students work are normally distributed and represented by the variable x. Now, a couple things in here is this is obviously not a community college where this would not be where your norm is. But what we want to look at this is we want to break down the language. If we're assuming things are normally distributed, we can map everything against the standard normal. So what we want to find is we want to find a standard deviation and a mean. Well, the word average and mean are the same. So I'm going to hop over to my Blackboard here. And using the data from that question, our mean was 22 hours. And the standard deviation was 9 hours. And we want the probability that if I selected someone at random, they would be less than 4. So we'll go back and look at the question, make sure I have everything there. All right, my average was 22, that's right. Standard deviation is 9, and we want to find the probability that the student worked for less than 4 hours per week. So what we want to do is we want to find a z-score. Now, I'm not going to draw the normal until I have a z-score. Then once I have the z-score, I'm going to draw the normal distribution. So my z is x minus mu over the standard deviation. And so in this case, my x is 4. Good. And now saying less than 4, it's everything up until 4. Minus 22 divided by 9. Now 4 minus 22 is negative 18 divided by 9. And so my z-score is negative 2. So now if I draw my standard normal, I'm looking for the probability, which is equivalent to the area of everything up to a z-score of negative 2. So I'm going to come to my table, and in my table I'm going to go to the negative z-scores. So that's page 6 of the PDF. Come down to -2, and a -2.00. And so that's the very last one here, which is 0.0228. And so the probability of x being less than 4 is 0.02. Make sure I'm reading this right. 28. Repetitive numbers are really hard for me to remember when I flip pages of things. 28. Like if there's a repeat in it, I never remember how many repeats to go. Well, this is the same as saying 2.28%. Right? Move the decimal place over 2. And so if I had this normalized distribution of people with what their average hours were, I knew the standard deviation, and I were randomly grabbing it, there would be a 2.28% chance that someone I picked would work less than 4 hours. All right. And so this is why we look at these z-scores. This is why we focus on the z-scores, because they can take any distribution and have it map onto the normal, the standard normal. And because we know the probability values for a standard normal, we can now start talking about the odds of anything we observe if we can be assured that it's close to being normal. And what we'll talk about next time is what it means to be normal, how we can assume things are normal, how we can make sure it's random enough that this technique will work for us, and that these one set of tables will give us the probabilities within any statistical sizing. All right, so looking at, this is all I have material-wise for right now, but looking at a couple things. On both sections of this, there is a PDF now that has the tables. That there are the ones from the book, which is the ones I'll be using as the examples there. Yeah, they do open up in Blackboard, but you should be able to download them if need be. 2, the PowerPoint slides are up there. Download them as PDF, and you can pull up any of the PowerPoints that I have gone through for reference. 2, if you need to go back or forth, let me know. Again, there's enough of a delay here, and that delay can be magnified, right? If you're watching it live and your connection skips, it will pause a bit, and you will be watching it as if there was no skip, but you might fall a few seconds behind. I've noticed this. So in my own 092 class this morning, someone dropped their connection. They didn't realize it, and they ended up being like 30 seconds. They were more like, actually, a minute and a half behind on it. There is a fix for that if every now and again I take my little red slider. Here, let me see if I can show this to you here. Browser. Yeah. I take this little red slider down in the bottom and I move it over to the right. So I can actually watch this video from any point in time, and it's no longer quite live. And if I want it to catch back up to being live, I have to slide all the way over to the right. And what will happen is you'll see the red dot underneath live. That means you're in tune to where it's at. And so if your connection ever bubbles, you'll sometimes find you're back a bit. You don't get this live underneath it, but you can pull it back over to the right, and that live will come back on. And I've noticed that now where that has happened. Probably has happened in more classes than I knew about, but this morning, and I think with some of the questions that came in through here, that might have happened a bit. So it's something to just check out on there. All right, I am going to, so my agenda tonight is I'm going to continue recording the examples and putting them on the playlist for the Chapter 4 review material. I'll have the samples for that. Anyone that has a homework question, I've been pointing you to a similar problem if I've already had it recorded, or recording an example of that. Those will all go into that playlist. So make sure you can access that playlist and you can look to see whatever's being done. I'm also, now that we're on new material, I'm going to take some of the examples I didn't cover and I'm going to focus on them in smaller batches. I will try to, whenever a calculation comes up, do two forms in an example. One, as if you have the TI-84 Plus, and the other as if you're using the TI-30. For most of the normal distribution stuff we're doing, the TI-30 will be using those tables. So try to print out those tables or have a copy of them somewhere ready. They are probably the most used thing from now up until chapter 9, really. We will keep going back to either the standard normal table or a T distribution table. That's everything I have today. I apologize for some of the hiccups here. I am trying to copy the material between the two courses. I will have, by the end of this week, by Friday, all of the PowerPoint slides up so you can have those for references. I will also try to have all of the links coming through. I will, again, on Tuesdays, try to send an email where the due dates and everything are at, and try to keep them coming across. If you have any specific questions, please email me. I try to be 24 hours on email. I am behind on email. I have gotten it to where I am within this week. I'm trying to catch up, and so that I can stay ahead. There was a lot of things I had to redesign, and some of the questions I got from people I was redesigning. Like for me right now, my biggest concern is I want to get a better camera than the one I have. So when I demo the calculators or anything, or if I have to do something on a piece of paper, it's viewable. So that is my big concern. But if your concern is something else, tell me. All right, that's all I have. I'm going to... well, you can drop out when you want to. I want to turn off the volume because you heard my boys running back and forth through all the different doors. I am sorry about that. I also am moving the room that I'm recording into our front porch, which isn't heated right now, but I'm hoping that we're in enough of the spring that I won't be freezing to death on it, and hopefully that'll get some of the background noise out of the way. I'm also moving to a standing desk because sitting down here I am just not as excited as I should be for this stuff, because we're really in exciting stuff. Normal distributions can solve so many things. The stuff's neat. And I should be jumping up and down. Instead, I'm just kind of rocking on my chair. Wait, and here, go get that. Me rocking on my chair. Rocking on my chair. Everyone, be safe, be well, all right? And I'll see you on the other side of homework for Chapter 5 coming out, all right? So... You're very welcome, Aisha. Thank you guys for keeping on. And now I'm going to mute the sound.